Now we discuss the correlation coefficient. Let me start with the definition. Correlation coefficient. Definition. Let x and y be random variables such that zero less than variance of x is less than finite and 0 less than variance of y less than finite quantity. That means the variance exists which is not equal to 0 for both the random variables x and y. Then the correlation coefficient between the random variables x and y is defined as, with the notation rho, we can use the notation suffix or we do not need. If the suffix is there, that means these two random variables. If the suffix is not there, the underlying random variables are two random variables. The correlation coefficient, that is same as covariance between the same two random variables divided by the positive square root of variance of x multiplied by positive square root of variance of y. Since these two comes in the denominator, we are making the restriction the variance has to be strictly greater than 0 for both x and y. This value is going to be called it as a correlation coefficient between the random variables x and y. I am going to give few results over the correlation coefficient. The first result, the correlation between x comma y, that is same as a correlation between y comma x. By interchanging the role of x and y, it is going to be the same value. Since the value is divided by covariance divided by square root of variance of x square root of variance of y, the absolute value of correlation coefficient is always less than or equal to 1. That means that the value is lies between -1 to 1. Third result, if you compute the correlation coefficient between the same random variables, that means the covariance of x comma x, that is nothing but the variance of x, and the denominator it becomes the variance of x. So, you will get the answer 1. That means a correlation coefficient between the same random variable, that becomes 1. Suppose you go for a correlation between x with minus x, then that quantity is going to be -1. The fourth result, that is the correlation coefficient of ax plus b, where a and b are constant, with the random variable y, that is going to be, if you use the results of covariance between any two random variable, when one random variable is ax plus b, the other one is y, use that result, you will get it is a correlation coefficient of x comma y for any constants a comma b with A is greater than 0. This can be proved, but we are not giving the proof of this result, but these results will be used again and again. As a fifth result, suppose the random variable x and y are independent. If the random variable x and y are independent, then we can conclude the correlation coefficient between these two random variable is going to be 0, because the correlation coefficient is same as covariance divided by positive square root of variance, positive square root of variance of y, and we know that if two random variables are independent, the covariance of x comma y is going to be 0. Therefore, the correlation coefficient is also going to be 0 when two random variables are independent. Whereas the converse is not true. The converse is not true. That means, if the correlation coefficient is 0 for two random variables, that does not imply those two random variables are independent. Now we are going to define the matrix related to the correlation coefficient. That is, now we are going to define a matrix which is related to the correlation coefficient. That is a correlation matrix. Let capital X is a random vector whose elements are x1, x2 and so on, xn be a random vector with individual variance of the random variable has to be not equal to 0, and it is a finite quantity for I is equal to 1, 2 and so on, all n random variables. Then the correlation matrix of the random vector capital X, which is denoted by the matrix called capital R, that is defined as capital R. Earlier we have used the notation sum, that is for the covariance variance matrix, and here we are using capital R for correlation matrix, whose elements are, the diagonal element is 1 and the second element is first row, second element is correlation coefficient between x1 with x2 and so on. The first row last element, that is the nth element, is a correlation coefficient between x1 with xn. Similarly, the second row, that is a correlation coefficient between x2 and x1, and the second row second element, that is 1 and so on. The second row nth column, that is a correlation coefficient between x2 with xn. Like that you can fill up n rows. So, the nth row first column, that is correlation coefficient between xn with x1. Like that the last element will be 1. Again this is a n cross n order matrix whose diagonal elements are 1 and other elements are for the ith row jth column, that is a correlation coefficient between xi and xj. We will go for the example, but we will take the example what we have discussed for the covariance variance matrix we will take the same example and find out the R matrix. That is, example is same as two-dimensional random variable with the joint probability density function is 1 divided by x1 when x1 takes a value 0 to 1 and x2 takes a value 0 to x1, 0 otherwise. We have already computed the expectation of x1, expectation of x2, expectation of x1 square, expectation of x2 square, then expectation of x1, x2. Using that we got the covariance between x1, x2 also and variance of x1 as well as variance of x2. Therefore, in the same example, the R matrix is going to be 2 cross 2 matrix 1, and the second element is a correlation coefficient between x1 with x2, and this is correlation coefficient between again x2 with x1, that is same as x1 with x2 because of symmetric, and last element is 1, that is 2 cross 2 matrix. So, we have to compute what is the correlation coefficient between x1 x2. So, correlation between x1 comma x2, that is covariance between x1 with x2 divided by square root of variance of x1 multiplied by square root of positive square root of variance of x2. So, we already got the covariance of x1 with x2, that is 1 divided by 24. Therefore, it is 1 divided by 24 divided by variance of x1 is 1 divided by 12, therefore, it is 1 divided by 12. Variance of x2 is 7 divided by 144, therefore, it is 7 divided by 144. You do the simplification, you will get the answer, that is 0.6546. Therefore, this R matrix is going to be 1.6546, 0.6546 1. That is going to be the correlation matrix for the same example which we have discussed earlier.